All right, well, we have quite a number of participants in here, so we will kick it off. Thanks everyone for joining today's webinar. There were over 300 of you who registered for this webinar, so we know that it is a really hot topic of AI and one that we are super excited to discuss with you today. So my name is Michaela Davis. I'm our digital marketing manager here at Bidgely, and I will be your host for today. So before I introduce your speaker today, we'll go over some quick housekeeping rules. So first and foremost, please ask all of the questions you want. You can utilize that Q&A feature on the Zoom webinar, and I will be monitoring this throughout the entire webinar and to make sure that you guys get as many of your questions answered as possible. And we're really here to provide that value back to you. Second, feel free to chat with attendees. There's an option to respond just to the host or to other attendees, so feel free to use that as well. After the webinar, please take a minute to answer our short post-webinar survey. It's only 3 questions, and it's really going to help us keep providing value through these webinars to you guys. And we want to hear about what webinar topics you guys want to see in 2024. And then lastly, this webinar is being recorded, so we will share the on-demand recording out with everyone who's registered for the webinar. So if you can only stay for the first half, or you have some colleagues who couldn't make it, don't worry, we will send it to you after. You can expect it within 24 hours. And then go ahead to the next slide. Without further ado, I'm excited to introduce you to our speaker today. We have Sriram Ramanathan. Sriram is our Chief of Staff at Bidgely and works on topics as diverse as strategy, growth, packaging, and pricing. Prior to joining Bidgely, he headed a digital transformation research and consulting team where he helped launch and grow several services, including artificial intelligence and industrial IoT. In this role, he guided C-suite executives in utilities and other sectors in establishing digital transformation roadmaps, identifying scalable use cases, and monetizing digital products via novel business models. Sriram is a recognized expert in artificial intelligence and has been invited to chair and present at various AI conferences, and has also been featured as a digital thought leader in multiple business magazines. So with that, I will hand it over to you, Sriram. Take it away.
Thank you very much, Michaela. This is a topic for everyone that's always been a passion for me for the past decade or so. So I've dived really deep, both on the technology side and as well as on the business side and use cases side. And I'm really excited to have you all here and to share my thoughts in terms of what it means for the utility of the future. So we're going to start off by looking at a few agenda items outline. Firstly, we're going to look at the emerging megatrends, how that's impacting the utilities sector, and specifically start looking into the role of AI here. But I also want to make the case that this time it's different. There's something different about AI, and so we're going to look under the hood with regards to the AI models and technologies that we at Bidgely have built, and how that is enabling real-world applications in the utility space. And then last but not the least, I want to talk about the hot topic of today, which is generative AI, how it's going to impact utilities. Why is it a game changer? And I would request you all to hang on to the last 2 slides, because I'm going to show you what we are doing at Bidgely using generative AI. With that, let's jump in. And again, feel free to throw your questions into the chat box or the Q&A, and we can definitely have a discussion around it. So you are all from the utility space, and I don't have to spend a lot of time mentioning this, that utility sector is at the intersection of multiple megatrends that's offering both opportunities and threats for you, right? Rising adoption of renewables. This is posing a challenge to managing your loads, load balancing, managing your supply demand, and also planning your infrastructure. Energy efficiency and electrification is another trend that's happening. This requires that you find the right customers to target at the right time so that they adopt some of these technologies or even buy into the incentives that you're providing. Increased EV adoption, which is just another way of thinking about electrification, except that the impact is much bigger both in terms of how it's going to have an effect on your grid infrastructure, but also some of these people, when vehicle to grid is enabled, are going to become prosumers. How is that going to affect your demand supply balances? DERs, particularly if you consider the fact that 40% of EV homes have solar and 40% of those with solar are actually going in with batteries. So definitely this is going to impact, again, your demand supply balances. And then importantly, while all this is happening, customer needs are changing, right? We are now dealing with customers who have dealt with iPhones for the past decade and a half. We are talking about customers who have dealt with Amazon and Netflix for about 2 decades. And clearly, they are going back to the traditional industries like yourself, and they're expecting that you come back there and basically provide a similar kind of experience, similar kinds of access to data, access to insights, and more importantly, letting them make decisions very, very easily about what they should do. And last but not the least, underlying all these megatrends are these constantly changing regulatory and incentive environment. The government is offering incentives, which in turn is like further pushing or enhancing some of these megatrends you're looking at. Now, clearly, this is a lot of pressure to handle. And what some consulting firms are talking about is that AI is going to be a game changer. AI is going to help you utility companies win in this energy transition. And indeed, I believe this to some extent, right? This is a timeline of the evolution of AI over the last 7 decades. And what you're seeing here is that, initially the developments are very, very slow in 1950s. But something happened in 2012. Now, before we go there have been some groundbreaking moments, like handwriting recognition is a good example. Apple Siri is a good example. But sometime in 2012, there was a big change. And you can see that all these clusters of dots, which resemble big changes in AI, big changes in capabilities of AI, happened within the last 10 years or so, right? Again, AI algos, they win the ImageNet competition, which is basically these computer vision algorithms have become better than humans in recognizing images. AlphaGo wins the World Go Championship, defeating a human being, and then GPT-3, GPT-4, DALL-E, and so on and so forth, right? But it's not just the clustering of these dots together, which shows like rapid acceleration and development. It is also that the smartness of AI has gone up, right? There are some tests to measure how these AI algorithms compare to humans. And back in 2017 or 2018, AI was as good as a 6-year-old, and today it's as good as a 9-year-old, right? We just have to wait for them to turn 13 and start throwing their teenage tantrums. So no wonder that many firms, many market research analysts, many consultants are talking about unlocking tens of trillions of dollars of value using AI, right? And granted, utilities is a smaller percentage of this, but nevertheless, just back of the envelope calculation show that utilities are going to still see hundreds of billions of dollars of benefit from AI based on some of these predictions. But yet, ground truth cannot be far from this. If you look at some statistics, 85 to 95% of digital transformation projects fail. So if you spend $100 million on this, you're going to get value for only about $5 to $15 million. The rest is all being flushed. 90% of data science and AI projects, they are developed in the lab and they don't even get deployed. And of the 10% that's deployed, only 30% of the AI projects actually get scaled across the entire organization. That's basically 3% of the money you spend on AI projects is actually getting scaled, right? And so I asked the question, can AI really help the utility companies despite all this acceleration in development, despite all the level of smartness or improvements in smartness of AI? So to understand whether AI is really going to help, and I believe this time it's different, we need to start looking under the hood. Going back to this timeline, what is interesting is that our company, Bijli, was actually founded just as that hockey stick growth in AI started back in 2012. And so we had this vision that something is changing with AI. And so we decided to jump in. with solutions for the utilities industry specifically, right? And our mission right from the beginning, what we stood for was we want to accelerate a clean energy future. But we want to do that by both enabling utilities and consumers to use that data, that consumption data, and make intelligent, smart decisions, basically data-driven decisions. And to do that, we have built a series of machine learning algorithms over the past decade. So one good example here is unsupervised clustering. So in the past, what used to happen with data science and AI was that people used, human beings had to actually come in and classify the different data sets, which in this case, I'm showing as circles, triangles, and squares. And we built some unique, unsupervised clustering techniques that look at the data, automatically figure out what the signatures are. And based on that signatures, they actually label the data, right? And we applied that to the utility space. What is the benefit? How is it relevant to utilities? Think about your power consumption at a particular home. So this chart down here shows the amount of power consumed over a 24-hour period. And because we are able to use unsupervised clustering, what we are able to do is figure out the signatures for different appliances. Now, I'm sorry, my computer rebooted.
Yes, you're back.
Really funny that I'm doing a webinar on artificial intelligence. So I do apologize for that glitch, but hopefully we can be smooth going forward. So once again, so continuing on, one of the things, as I was mentioning, the ability to do unsupervised clustering actually allows us to figure out what are the different appliances, how much power they are consuming. Each of these appliances are consuming when they are turning on and turning off. So look at the blue bumps at the bottom, for example. The tiny little bumps that you see are basically a refrigerator that's running 24 hours a day, but turning on and off again and again, but consuming very small amount of power. And on the other hand, if you look at this light blue big peak at the beginning, it's classic of an EV, which consumes a huge amount of power, but just for a period of about 3 or 4 hours. So using unsupervised clustering, we are actually able to dive into that overall power consumption and break it up or disaggregate that into multiple appliances. And once we do that unsupervised clustering, once we turn it on, once we have trained the algorithms, this pretty much happens on an automatic basis with new data sets. So new data sets come in, they're automatically labeled using unsupervised training, and eventually we can do pattern recognition with that. Once we recognize patterns, we can also use other kinds of time series data to figure out energy trends in multiple homes. So remember, different homes are different. Some people have EVs, some people might have a home as just a vacation home. So it's important to not average everything, but rather split them up depending on what groups or what categories or classes they fall into, and then extrapolate those trends, right? And predict the future. So for example, on the top here, somebody might have purchased an EV and their consumption has been going up continuously. On the right here, perhaps it's just staying steady. And in the bottom here, perhaps there was a peak because most of these people in that cluster have a vacation homes. They just use it for a few weeks and then they turn off all the heating and all the appliances there. And then once we do that, we are able to actually use machine learning algorithms to forecast future trends. Now, we also have 17 patents around this. Our algorithms work with absolutely no hardware needed, absolutely no input from customers that are needed. And this is applicable for a wide range of meters, not necessarily just smart meters, but we can also do it with like traditional meters, except on a monthly basis. And this is what you see on the left here is really a heat map. So the y-axis here represents 365 days of data for a year. And on the x-axis actually represents 24 hours. So this is energy consumption for a single home for a whole year, hour by hour or minute by minute, depending on what the resolution of that AMI is. But notice that there are lots of patterns, right? So the brightest part in this heat map actually correspond to high amounts of energy consumption, and the darkest parts actually correspond to low amounts of energy consumption. But very clearly, we are able to pull out a lot of interesting information here, such as when is a pool pump running, or when is the heating running, and so on. But we can dive even deeper than that, right? Using our machine learning algorithms. We can find out, is an appliance inefficient, right? Has somebody gone on vacation? What kind of appliances are being used? When are they being used? Does somebody have a solar? Does somebody have an EV? And so on and so forth. And we can do this with very high amounts of accuracy. Detecting those appliances, we can hit 90% plus accuracies. And with regards to consumption, how much watts they are consuming, we can hit 80, 85% plus accuracies for many of these different appliances. But now you might wonder, oh my God, these guys are going to give me a product that's going to spit out a bunch of numbers. And what am I supposed to do with these numbers? Well, the answer is no. What, again, we have done over the past 10 years is basically productize this whole solution. And we essentially have an out-of-the-box plug-and-play solution pretty much. So we built it in 3 layers. We have a data lake layer, which takes the AMI data, but also takes a lot of third-party data, weather data, or demographic data, or home ownership data. We have an AI ML layer, which I talked about earlier, but all of this is getting rolled up into business intelligence tools like Looker. So somebody, a business manager with no background in data science, can just look at these charts and right away get some interesting insights out of those charts. And so effectively, if you remember in the initial, somewhere in the beginning, I pointed out to how so many projects, AI projects fail. That is one of the things that we have achieved. We have managed to de-risk it. We have managed to reduce the number of failures you will have with these kinds of AI projects. But not only that, you don't have to pay millions for integration. You don't have to wait for a year, 2 years to launch some of these solutions. Some of these solutions can be launched within a few weeks or a couple of months. That's kind of the timeline we are talking about here. So as a result of us productizing this solution, as a result of us being able to offer out-of-the-box solutions, we have had remarkable traction with utilities. More than 40 utilities have adopted our solution. And overall, across these different utilities, we are serving 30 million plus end users. And you can see in these logos, some of these are really big names, well-recognized names. And I'll also be presenting some case studies later from some of these companies. So let's stop for a minute and find out what are some real-world applications that are enabled because of this out-of-the-box AI solution, this productized version of the AI solution. Again, I want to re-emphasize some of these megatrends because what we have done is we have built a whole solution suite that actually tries to tackle these megatrends, that actually helps the utilities address pressures that are arising from these megatrends. Very broadly, they focus on customer engagement, EV load management, analytics and targeting in particular, and finally, of course, planning your grid needs, right? Load research as well as infrastructure, grid infrastructure planning. What I'm going to do in the next few slides is dive into some of these solution groups to provide a deeper insight into what kind of use cases we are able to tackle using our AI platform. And also, if possible, provide some examples from specific utilities that we have worked with. So let's focus on customer engagement and energy efficiency. So HERs, or home energy reports, is something that's well known for a long, long time, for several decades at least. But the issue is that the previous generation of HERs were very statistical, and they were treating consumers in large cohorts. And that was fine in the previous world that we lived in. But now with adoption of EVs, heat pumps, other various kinds of pool pumps, and all these megatrends we are talking about, your HERs have to be really smart. They have to treat consumers at an individual level, right? So to give you an example, to emphasize on that, if you go to Bay Area and you look at two neighboring zip codes, one of the zip codes has 10 times more EVs compared to the next. And not only that, that adoption within a single zip code is very non-uniform. I have 2 neighbors with 3 EVs, but the rest of them don't have an EV. So how do you target someone specifically if you create statistical cohorts out of them? So you need a smart solution that we try to offer with our AI platform. And so in our platform, as I mentioned earlier, we used a range of different data streams not just AMI data, not just meter data, but also other things like property attributes, geography, and so on and so forth. And this allows us to enable use cases such as social benchmarking, right, in order to improve energy efficiency, or motivating homes in the same clusters to actually save energy. And here is also another example of the same heat map, how within that heat map, we are able to pick out people who are specifically on vacation. And this is very critical, because if you go to someone who was on vacation and they come back and their energy use increases dramatically, the last thing you want to do from a consumer experience perspective is go and tell them, hey, your energy use went up by 100%. They are just not going to trust your solution anymore. So it is critical to identify people who are on vacation and make sure that you don't send them the wrong insights or wrong notifications or even nudge them in the wrong direction.
Hey, Shriram, we have a question in the chat real quick. The question is, what data access is available via the data lake? Is it the raw data, the AI-derived data, i.e. predictions, or both?
So generally what we have, thank you very much. That's a very good question. Generally what we do is we don't directly provide access to the data lake itself to the utilities. What we try to do is offer insights directly, which are some of the charts that I was showing you earlier. And the reason is because most of the utilities actually prefer that. But within those insights, you don't have to necessarily just see charts. You might come and say, hey, I want to download a CSV of that data. And we do allow you to download the CSV of that data associated with some of those charts. The data lake can be a little dirty and it can be a little disorganized. And that's the reason we don't directly offer access. But that's something that's definitely worthwhile discussing. If you're interested, we are happy to have a discussion around that. Thank you, Michaela. So let me continue on with one interesting example from SDG&E. This was a utility that was actually working in the past with Oracle, who is in a similar HER space. But what is interesting is they came to us and they said, we want an HER solution that is smart, that's intelligent, that uses AI, and that can particularly identify solar and EV owners. And so as a consequence, we were able to get into that particular utility. And the outcome was, one, we were able to identify legacy solar customers who had been removed from the program and reintroduce them back into the program. But not only that, we were able to find a target population that was 150% bigger than what that original vendor was actually targeting. So we are now at close to about 1 million customers with this particular utility with regards to their HER program. Similar home comparisons. Remember, I was mentioning how it's absolutely important to separate out EV owners from non-EV owners, especially when it comes to HERs, because as you might imagine, my neighbor has an EV, similar home size, but unfortunately, they have an EV, and so their energy consumption is higher. And so as a consequence, they are really not the right home to compare me with. And one of the things that we are able to do is detect that EV and split it out, as you can see at the bottom, and then just take the non-EV part of the energy consumption and compare that with other homes, which is very critical because you don't want the consumers to get the wrong insights based on the energy consumption, especially if they are EV owners or they have more than one EV at their home. Let's look at another category of our solution suite, which is behind the meter targeting. One of the reasons you want to target, going back to the megatrends, is you might want to perhaps increase the amount of electrification in your region, or you might want to just target them from an energy efficiency perspective. And our heat maps, as you can see, our AI platform is able to generate those heat maps. And in these heat maps, you can see we can identify all kinds of things for targeting. Electric vehicles, definitely, I talked about that earlier, but HVAC degradation, saturated ACs, short cycles ACs, or even those with homes with smart thermostats versus no smart thermostats. What we do is we leverage very advanced image recognition algorithms. Now, when you look at this heat map right here, for a human eye, it's very easy to see that there's a sudden transition happening. You can see that edge here in the middle of the picture going up vertically. That is the start of a pool pump. But unfortunately, computers cannot do that. You really need advanced image recognition algorithms that can go from this first picture to the second picture saying, here is where the edges are, clean them up, detect where the final edges are, basically remove all the noise, and then finally come and say, here's the consumption pattern for a particular pool pump. And with these advanced algorithms, what we are able to do is we are able to differentiate between single speed, variable speed pool pumps, figure out when they turn on, when they turn off, and even measure how much power they are actually consuming. So here's an example from a prominent Southwestern utility with whom we work very closely. They wanted our help with regards to identifying inefficient appliances. And you can see in both these charts, the left one focusing on cooling, the right one focusing on heating, we were able to detect saturation, we are able to detect short cycling, and notice at the bottom, in terms of numbers, there is almost 2 million cooling systems that had short cycling issues. So imagine what kind of an opportunity that it offers you in terms of energy savings or in terms of making that clean energy transition or enabling that clean energy transition. This is an example from Avista. Avista was interested in finding out who are the candidates in their region of operation who are good candidates for heat pumps. And they were able to do that within minutes. It took them about 3 hours to pull the number and type of customers on 40 different feeders using our analytic solutions. And this, by the way, is a 100x improvement over traditional methods, which they mentioned, they told us, used to take as much as 160 hours. And we are expecting or anticipating about 1 megawatt of demand flexibility that will likely be unlocked because of this. I see a question in the chat, which is about, Brandon, thanks for asking that question. What granularity of consumption data is needed to reasonably predict the type of load, EV, pool pump, inefficient, HVAC, and so on? So we can work with all levels of granularity. Obviously the AMI data with 15 minutes of data is the best. It gives you the highest amounts of accuracy. And it also can kind of tell you on a minute by minute or hour by hour basis when that consumption is going up. Is it going up at 4 p.m., coming down at 8 p.m., and so on. But we can also work with monthly data. Obviously, you lose that granularity with regards to on a day-to-day basis or an hour-to-hour basis, how that consumption is changing. But also, once you move to monthly data, your accuracy tends to drop a little bit, but it is really not so far off from the AMI, 15-minute AMI data. So we can even work with monthly data, which is what traditional meters do in terms of energy consumption and so on. So I hope that answers your question. There's another question that I see here, may have already been stated, but does a utility have to have AMI in order to benefit? I think I just answered that. No, you don't need to have an AMI. In fact, we have a lot of customers who do have NSMs, and we do work with folks who are using NSMs, who have NSMs, and we have engagements going on with them. Okay, so let me continue with this.
Sorry, Shriram, there's one other question in the Q&A part of the chat that says, regarding inefficient appliances, what's the rate of accuracy?
So the rate of I think in terms of accuracy, in terms of what, so if you remember that chart or that table I showed you with regards to, there are two kinds of accuracy. Detection accuracy, that's not a problem. We can get 90% plus. And then there's a consumption accuracy, which is 80, 85% plus, depending on the appliance that you're looking at. And what we are doing is, in terms of detecting saturation and so on, all we are doing is trying to figure out the consumption of an inefficient appliance, trying to find out the typical consumption of an efficient appliance, and we can compare them. So that accuracy is basically very similar to what you would see for that consumption accuracy, which is around 85, 90%. And again, it depends on the appliance, which is why I'm not committing to a specific number here. Hope that answers your question. Again, anybody who has further questions, we are happy to have a conversation with you after the webinar. Please feel free to reach out, and we can definitely have a conversation. So let's kind of focus on the next solution suite, which is related to EV load management. One of the things, again, going back to the heat map here, you can know, so you typically the input data, which is the raw data, which is shown on the left here, is all the power consumption. And from that, we are able to filter out just the EV related data, which is shown as some of the yellow and red bars that you see on in the right heat map here. But what's interesting is the level of detail to which we can go. It's not just about saying, hey, do you have an EV or not, and how much you're consuming. We can go down to what type of a charger do they have? What's the amplitude of that charger? How many times have they charged during peak hours? When do they typically start charging? When do they typically end charging? And so on and so forth. And we roll this data up. You will not just have to see a heat map and figure all that out. We roll this data up into all kinds of interesting bar charts, pie charts, and so on at a cohort level. So for example, we have taken this data in a particular region for EVs, and you can see on the top chart here, we have plotted the number of EV owners versus the number of charging sessions per week, which is the EV charging frequency histogram. And at the bottom, you have a similar kind of a histogram, but for the charging duration, where we show how many EV owners charge for different number of hours during the day. And then there are all kinds of heat maps. So basically the person who is using this, the business manager who is using this, has the ability to play around with the data, filter the data as they need, filter it by zip codes, filter it by regions, and so on and so forth. And I definitely encourage you to come to us, reach out to us for a demo of the platform, because there are at least a couple of dozen filters that you can apply and find out, like how you can play around with that data and get all kinds of interesting information out of it. So this is a case study. We worked with a Midwestern utility who wanted to target EV specifically. So we worked with them on 2 zip codes. There were 10,000 customers in those 2 zip codes, from which we right away figured out that only about 250 people have EVs. From that, we were actually able to filter down to figure out who are those people who are charging 70% or more of their more of the time during peak hours. And we found there are about 130 of those customers roughly. And of those, we were able to find out how many of them have high amplitude chargers. So now, once you have this data, and if you want to shift the load, it is really a matter of, encouraging them through time of use or other kinds of incentives. And we figured that there's at least about a potential to shift about nearly 230 megawatt hours per year simply by enrolling them into some kind of a program, managed charging or a time of use program. This is a case study from PSEG Long Island, with whom we have been working very closely. The chart at the top, and this is on a time of use program that we implemented for them. The chart at the top, the 2 lines you want to pay attention to is the green ones and the red ones. The red one shows the percentage of people who are charging during peak hours, and the green one shows percentage that are charging during off-peak hours. And this is, the top chart is when they were not enrolled in the TOU program. But once we implemented our solution, notice how much of a shift you see. Almost 80% of the people actually shifted to charging during off-peak hours. And what's also interesting is that we were able to achieve a 26% reduction in the on-peak charging through TOU coaching, and the amount of enrollment was also close to about 20% here. Finally, I want to focus on our grid planning load research solutions. What we also do is, remember, we are collecting these heat maps at the individual meter level, but over time, we also roll it up into higher and higher levels of granularity. So in this case, we have taken all the homes that fall under different substations. We have rolled up that 8760 data that you see at the top here, the chart that you see at the top here. By the way, these different colors actually represent the contributions of different types of appliances. So again, if you come to the demo, you could click on this, say the blue one, and say, hey, I want to filter out only people who are, let's say the blue curve was associated with HVACs. I want to only focus on those who are consuming, most of their consumption is coming from HVACs. But at the bottom, what you see is that at the substation level, we are able to capture everything. How much is the demand? What is the hourly average demand? What is the hourly maximum demand? And most importantly, what's that utilization of the substation depending on what the capacity is? And so this allows you to plan that, oh, these two substations are at capacity and I need to upgrade them today so that we don't run into problems into the future. But this tool also goes even beyond that. What you can also do is you can start building all kinds of scenarios, right? So you can say, I want to look into the next 5 or 10 years. I want to incorporate various kinds of growth scenarios like EV growth scenario, population growth scenario, demographic shifts, and so on, and then look at how things are going to change at the substation level. So we talked a lot about traditional AI, the kinds of machine learning algorithms that we have built at Bijli and how we have productized it and made it an out-of-the-box solution. What I want to focus on is the final piece here. What does generative AI mean for utilities? But before I go into that, I want to explain what is different about generative AI. Why are people so gung-ho about it? This goes beyond ChatGPT. But today, if you read the news, everybody is talking about, oh, GPT-4 passed the bar exam and it passed with flying colors with LSAT and so on and so forth. In fact, I read a piece of news where GPT-4 apparently cleared the Mensa test. Mensa is a test for admitting some of the most brilliant people into a group, right? And so this does seem really, really smart. So the question is, why is generative AI so smart? Why is it so creative? Why is it a game changer? Why is the step change happening because of generative AI compared to traditional AI algorithms? To understand that, we need to understand how the human brain works, right? If you look at the human brain, its ability to store data is not much. It can store about a terabyte of data. So the question is, how did we get to where we are today? Like, how are we able to put humans on the moon? How are we able to send spacecrafts to Mars and beyond? How are we able to build these massive buildings and bridges and so on? The answer lies in what is known as reductionism. Our brain doesn't store all the data. What we try to do is we try to come up with models that explain the data. Models like Newton's laws of motion, or it might just be a simple straight line that goes through a bunch of data, and we say, we are going to use this straight line in the future to represent all that data that comes in. But it's because of this reductionism that we are also very creative, right? Sometimes you find data sets that are not fitting that trend, fitting that model, and so we try to extrapolate. We try to be creative. And that's what generative AI does. If you take a traditional AI algorithm and show an elephant, it will capture every pixel on that elephant and try to describe that elephant in excruciating detail. And so if you go to this AI algorithm and say, hey, draw me an elephant, what it's going to do is that it is basically going to draw the same elephant again and again, right? But generative AI builds a model of that elephant. It says, an elephant is something that has big fan-like ears, it has pillar-like legs, it has a rope-like tail, et cetera, et cetera. And so now when you ask generative AI to draw that elephant, each time it draws that elephant is going to look different. Pretty much like a 6-year-old trying to draw that elephant again and again, and you get different versions of that elephant every time, right? Sometimes the trunk could be on top of that, of the hump of the elephant, which is very odd, but that's how it's creative. That's how it's trying to show its creativity. And this is why generative AI can create these really realistic looking photos, but that are absolutely implausible, like this elephant that's standing on the wing of a plane. So what are the implications for the real world? The implications for the real world go beyond ChatGPT, go beyond saying, hey, tell me about this particular recipe, and ChatGPT spits out something. For example, and a lot of these are simulations and tests that have been done. People are just about starting to implement these in the real world. So in this test, Microsoft did this test, and they are a big investor in OpenAI, which developed ChatGPT. they said a human being went to this GPT algorithm and said, hey, I have a leak in my kitchen ceiling. Tell me how to fix it, right? And this generative AI comes back and says, is your kitchen below a bathroom? And the human replies, yes. And then the generative AI comes and says, is this leak under a bathtub or a toilet? And the human being says it seems to be under the bathtub. Then generative AI comes and tells the human that either you check your caulking, and if the caulking is okay around the bathtub, you probably have to regrout your tiles because the grout is probably failing and the water is leaking through those tiles. So again, you might imagine this is not that creative, but remember, 99% of us, we are not Einsteins or Newtons trying to develop a brand new paradigm for the world. All we are trying to do is have that incremental creativity. I call it duct tape creativity to fix problems that are around us. And definitely the algorithm is very, very capable of fixing day-to-day problems around us. Another example from robotics. Typically today, if you want to program a robot, you can spend hours and hours trying to program that robot. But today, as you see in this example, Microsoft went to GPT and said, hey, I want you to go fly in at this particular angle and inspect the second wind blade on that particular wind turbine. GPT takes that instruction, converts that to a robotic code, a program, and the drone is actually able to fly, do exactly what the human being requested, and come back. And this has implications, right? Important implications, because now this robotic technology becomes all the more scalable compared to earlier, where every time you had a different environment, you had to reprogram that whole robot. So like in the case of AI, when AI took off in 2012, Bidgely actually, we had the vision and we invested in AI thinking this is going to be a game changer, and we decided to target the utility industry. And today we have the same vision. We realize GPT is a big game changer, and we have already started investing in the space, innovating in the space. So let me show you two examples of how exactly we are innovating in this particular space. And these are videos, demos of what we are building right now. So the first one is focused on the customer experience, right? So there's a consumer who notes that, oh my God, my electricity bill is much higher than normal. So enter EnerGPT. We call this platform we're working on as EnerGPT. The user comes and says, hey, is there something abnormal happening this month? Natural language. The GPT goes on the back end, interacts with the data, and gives a natural language response with charts saying your daily cost seems to have gone up nearly 40%, right? And then the user comes and says, oh, did I start using more electricity? And EnerGPT again interacts with the data on the back end and says, no, your usage is normal, something else is wrong. And so the user now says, okay, I am really confused. You got to tell me what exactly is going on. Why did my daily cost actually go up, right? So then EnerGPT comes in, again, looks at the data, analyzes it, and then responses in a very simple human language in a fashion, similar to what a CSR, a customer service representative, would do, saying, hey, your pool pump is operating at the wrong hours. It's operating during peak hours, and throws a chart. And after that, it also offers a solution saying, go back, reset the timer on your pool pump, reprogram it so that it tends to run during off-peak hours, which, by the way, it is totally determined by the utility. Different utilities have different off-peak hours, and therefore it can, you can program all that in also. So this is a good example of how generative AI can be a game changer from a customer experience perspective. But the same stands on the sorry, I'm trying to go to the next slide. Same stands on the grid side as well. So think about an operational manager who's struggling to make sense of what's happening with all these assets. And so this is where, again, EnerGPT can play a very critical role, because it's an intelligent chatbot that can actually go on the back end, analyze data, and provide simple responses to the operational manager. So in this case, the operations manager comes and asks, what are the top 5 substations with like highest solar generation? It generates a list right away. And then it tries to, and then the operations manager comes and says, hey, show me the 8760, which is the power consumption for the entire year. And right away, EnergyPT is able to generate that chart for the top consumer, the top substation with solar, showing that entire thing. But then it starts diving deeper depending on the requests of that particular operations manager, right? Looking at the load profile, for example, with both of homes with only EV and solar, nothing else, right? It's able to break it down and show how that consumption is changing hour by hour. But you can filter down even further from a targeting perspective. How many EVs do we have? Right? It tells you all the number of EVs. And then you can find out even how many of those EV owners actually have solar available. And that's the next question the operations managers asks. And it tells you that there are these many number of residences that actually also have EV as well as solar. In this case, about 50 out of the 150 residences. So notice how it is able to generate these charts, interact with the data, come back to that operations manager with like very clear-cut responses. And finally, you can even download that list in a CSV fashion if you want, so that you can then determine what's the next action you want to take. So with that, I want to end this webinar with some key takeaways, right? So it's very clear, you all know this, utilities are under pressure to transform themselves, right? There's a lot of megatrends that are coming together to place pressure on utilities. Now, don't get me wrong, there are many organizations that are developing these AI kind of solutions, but very few like us, like Bijali, have built an out-of-the-box AI platform that's really scalable, that can tackle a wide range of use cases, both across the consumer side as well as the operations side. And we also are able to dramatically reduce that risk of AI failure. Remember that the data I was showing earlier, the statistics that I was showing earlier, how only 3% of the AI projects come out of the lab and are scaled across the organization. That's something that we have fixed by productizing our solution. So again, talk to us, come to us. We will try to help you figure out how you can use this AI platform to address different use cases. Or if you just want to learn more about how generative AI can have a big impact on your industry for your company, come talk to us, and we are more than happy to have that conversation. Thank you very much. I'm happy to take any more questions you might have. So I see one question out here, which is participants likely don't know the acronym NSM. Yes, I apologize. NSM is basically non-smart meters, which is not AMIs basically. And these are the meters that typically collect data on a monthly basis.
There's another question, Sriram. What are some of the challenges around adopting generative AI in the utility space?
Yeah, that's a very good question. So one of the biggest challenges is the amount of training data that you need. ChatGPT has been built by training on all the documents that are available on the web, freely available on the web. That's a huge amount of information. Unfortunately, if you think about manufacturing industries like yourself, the amount of data that you would have, raw data you would have for training these algorithms is a lot smaller. Now, people are working on technologies like zero-shot learning, one-shot learning that can fix this issue. So that's one big issue that needs to be fixed. The second is these algorithms are still not very, very stable. They are somewhat unstable. And you can test this on ChatGPT once in a while. It'll throw responses that are not accurate or that are incorrect. So you definitely need to be a little careful. And finally, the amount of cloud power that you need today is huge. But again, there are technologies working on shrinking these algorithms, making sure they can run on something smaller like a desktop computer, or at least a powerful server at this point. So those are some challenges that need to be overcome. But looking at how people have overcome these challenges in the past with AI, I would imagine in the next 3 to 5 years, we are really going to see dramatic changes, which are going to address or overcome these challenges.
Awesome. And then we have another one in the Q&A chat. Is it mainly AMI data that your team would need to get some of these off the ground? What about program enrollments, energy store purchases? Have you worked with any utilities that have provided that data?
Yes, we have worked with other utilities that have done program enrollments and so on. In some cases, we have also worked with energy store purchases. But like I said, we are able to incorporate a lot of different data sets, and in some situations we can customize it. But again, I think it is worthwhile diving deeper, trying to figure out what your use case is. So if you reach out to us, we are definitely happy to answer those questions in a more in-depth conversation.
And then we have another question that is, human psychology is of course a core element of behavioral programs. How would a utility avoid coming across as big brother when presenting this data to customers?
Yeah, so we have not seen a lot of pushback. In fact, customers are basically looking for, as I mentioned earlier, the idea of customer experience is changing. These customers in the past, 20 years ago, have been very, very hesitant with companies coming in and taking the data and offering insights. But today we are in the world of Google and Amazon and Facebook and Netflix, and everybody has accepted the fact that our data is being used. But as long as it's being used to enhance the experience they have, they are not very resistant towards that. And with those 30 or 40 plus utilities we have worked in the past, we have had tremendous success. We have been able to take that data, analyze it, offer insights to customers either through HERs or perhaps in terms of targeting. And generally, the feedback has been very positive. In fact, we do surveys through our platform, through our this thing, and we have found overwhelmingly positive responses. 80% plus people saying, "Oh, we love this," giving us a thumbs up.
Okay, I think we have time for one more, and it is, what are some other uses for generative AI in the utility sector?
Yeah, that's a very good question. I did skirt upon that issue. We just talked about the interfaces that we are building. But remember, one of the key aspects that I highlighted was generative AI is very, very creative. So any task that requires, any use case that requires creativity is where you would want to use generative AI in the future. So if you want me to differentiate between non-AI versus traditional AI versus generative AI, here are 3 use cases that fit into each of those buckets. So let's say you want to do, for marketing purposes, a cohort level, a population level analysis. That is something a traditional non-AI algorithm will be able to handle, which is what people have done in the past. This analysis has been performed way back in mid 90s when AI was still not that hot. Traditional AI can do the kinds of things that we were showing, how to uniquely hyper-personalize the journey for customers, identify individual customers that you want to target based on their EV ownership or based on their HVAC efficiency and so on. But generative AI gets very, very interesting for things like, let's say, you want to automatically, balance your grid, or you want to make those decisions. Today, a lot of those decisions are being made by humans. Or let's say you want to figure out where your EV charging network, how should you, EV infrastructure, charging infrastructure, where do you install them? Again, human beings are being creative, extrapolating where human population and EV population is going to go and making decisions based on that. It requires creativity, and that's where generative AI can play a critical role in the future. So, and there are lots of other use cases I can talk about, but again, we don't have much time here. Happy to have that conversation if you're interested in learning more about that.
Awesome. Well, I don't see any more questions in the chat. So thank you so much, Sriram, for sharing your knowledge and insights on AI. And thank you to everyone who joined our webinar today. I hope you found it as interesting and enjoyable as I did. Once again, if you guys could please take a few minutes to answer our survey. I'll also paste the link into the chat right now. I'd really appreciate it if you could answer. There's only 3 questions, and it also has an option to request a one-on-one demo of our platform if you're interested in seeing more. Also, as a reminder, we will be sending the recording out to everyone who has registered, and you can feel free to share this with your colleagues who might be interested in this topic as well. And look out for other webinars we'll have in 2024. Thank you everyone for joining. Thank you, Sriram. And we'll see you next time.
Thank you everyone for your attention.